Welcome everyone. Thank you for joining us. My name is Gabe Arnold. I'm the Technical Director for the DLC. I'm hailing from the Northeast US, which we woke up to snow today. And so the schools are closed and daycare is closed. And if you hear any children hooting and hollering in the background, that's what that's about. We hope that you are staying warm and dry wherever you might be. I will be presenting the introduction here today before handing off to my colleagues who I will introduce now. Along with me, we have Axel Pearson. He is the project manager for the version 5.0 revision effort, and he is also the technical lead for the Efficacy and Flickr proposals. Axel will be presenting those parts. We also have Uta Baesnecker, who is DLC's technical manager for lighting quality. She has been leading the quality of light aspects of this version 5.0 proposal, including spectral quality, glare, and light distribution, and that's the part she will be presenting. Finally, we have Damon Bassetti, who leads DLC's efforts with horticultural lighting and some of our lighting controls initiatives. Damon has led the controllability aspect of this version 5.0 proposal, and he'll be presenting that part. Before we get going, we want to especially thank all of you for sharing your time with us on this webinar today and with reviewing the version 5.0 draft and submitting comments. We know this takes a lot of time, and we know our requirements have a lot of impact, and we really need and value your input in order to make this proposal work best for everyone. Let's begin with the agenda. We're going to start with an introduction before going into each individual topic that was proposed as part of version 5.0. This will include a discussion of the efficacy proposal, the quality of light proposals, and the controllability proposals before concluding with a discussion of other topics and a wrap-up and next steps. The webinar is being recorded, so if you or any of your colleagues miss it and would like to view it later, it will be posted to the DLC website under the news and events or on our webinars page. We have a lot of people on the webinar here today, so everyone will remain on mute through the duration of the webinar. If you experience any technical issues, you can let us know through the chat interface or through the question interface. We'll be watching that closely. We do encourage you to submit questions and comments to us through the course of the webinar. And you can do that through the GoToWebinar interface. The more simple clarifying questions that are submitted through the webinar, we will try to answer these as we go. However, any more detailed technical questions, which you're welcome to submit, we would like you to formally submit them through your comment forms, and we will not be answering them during the webinar, but it's helpful for us to know about them. I'd like to talk through how we'd like you to actually submit those. To submit comments and questions, we have a comment form that you can download from our website. Using this form is the best way to ensure that your comments are included and considered. In this case, we've prepared a specific comment form for this version 5.0 proposal. It's an Excel spreadsheet, and it has different tabs for the different topics of the proposal. We've also pre-populated it with some of the key questions we are looking for your perspective to answer. So please make sure to download and use this form to submit both your comments and your questions back to us. Some important points here. This draft is issued as a conceptual draft. That means we haven't included the detailed specification language and requirements or the details of how we'll implement the requirements that will appear in the final version. Implementation questions such as when and how existing products will need to be updated to meet the new requirements haven't been included or proposed. This was intentional. We are proposing a lot of new concepts here, new topic areas the DLC requirements will address, and new metrics we are proposing to use. Before getting too far and proposing specific details, we want to hear from you. 2 questions that we've prompted with this draft. What are your major questions and complicating issues with what's proposed in the draft? And importantly, What are your ideas, solutions, or preferences to address the questions and issues that you have raised? These are the two things we are especially looking to hear your feedback about. We'd like to give you a couple of examples here of how you might submit some of your questions and comments. We've already received a number of questions by email, and so here's an example of one that we'd like to go over and how you might address it in your comment form. A question that came in said, DLC, and trying to prepare comments for this, our teams are continually asking what happens to our existing product listings? What's the transition plan? And that's absolutely a critical issue. We understand that, but we haven't proposed a transition plan in the draft. Rather, this is an example of a major question or complicating issue we'd like you to include in your comments. So I've provided an example here on the right side of the slide for how you might submit this question. And so under the topic and description, you've identified this as something related to the transition period. And under comment and rationale, what you might do is first list your comment or question and then rationale for why it's important. So here you might say, what is the transition process and period by which existing listed products must comply with the new standards? And then tell us about why this is important, why it matters. So you might say, we have over 3,000 products already listed and in distribution where our customers are expecting them to be qualified. The DLC should allow time for existing inventory to be sold and for manufacturers to update their products and listings. In the column to the right, the proposed change or potential solution, this would be where you would propose what solution you would like to see for the issue you're raising, or what answer you would like to hear for the question you're raising. So here you might say, the DLC should allow at least, let's say, 6 months from the time the final requirements are published before any products are delisted to allow time for existing inventory to be sold, for products to be modified to meet the new standard, for new testing to be done, and new applications submitted to DLC. So this is the approach we'd like you to take. It's essentially identify a major question or issue, and as you are comfortable doing so, provide us what you'd like the answer to be and why. We know this approach is unconventional, but it's helpful to us in trying to make sure that when we do put forward a specific proposal with the next draft, it is aligned as possible with what you might be looking for. We have a second example here, and not to belabor the point, but this is another question that we've received. We were asked, would the flicker tests need to be performed by an LM79 approved lab, or can non-approved labs or manufacturers submit flicker test information? Obviously, a very important question. And so the way you might approach it in your comment form is first to ask the question, as we've done under comment and rationale here, and then tell us why it's important. Pointing out that flicker testing costs, if required, from an approved laboratory would be cost prohibitive, estimated at XX dollars per product. This sort of specific information is really helpful to us beyond just telling us something is going to be cost prohibitive. It's much more actionable and useful to us if you can tell us in what way it is cost prohibitive or how much it's cost prohibitive. And then in the proposed change or potential solution, tell us what you would like DLC to do. And so you might say the DLC should allow for flicker tests from the manufacturer as long as tests show appropriate results based on the standards. You might acknowledge that the DLC may not be able to always take manufacturers' word here, and there may need to be some system to ensure that what's being provided has some rigor behind it. And so you might suggest that the DLC can audit the manufacturer or surveil products to verify the manufacturer submitted data is accurate. So for all the questions that you are identifying as you're reviewing the draft, along with the issues that you are identifying, please do provide them to us through the form, along with what your proposed response would be and why. I have one more logistical slide here before we get into what's in the draft itself, the timeline. You can find in the draft proposal and on our website the timeline you see here. The DLC process for revisions typically includes 2 drafts for stakeholder comments before a final is published, which is currently shown at the end of September 2019 or early October 2019. That's the first date. There's kind of 3 dates in sequence. Following this publishing date, we have what's called an effective date, and that's what's highlighted in green here. This is when we start accepting products according to the new requirements. It takes time to build the IT and application systems around the new final published policy, and so that's why there's a delay to the actual effective date. That's currently projected right now for January 1st of 2020. And then following this, there is a third date, which is a delisting date. We typically allow a grace period for products that do not meet the requirements to remain on the list for a period of time so that manufacturers can update the products or listings to meet the new requirements before anything is delisted. So we want to make sure that this sequence of dates and the process is understood, and also make a point here that this target effective date is subject to change. It's not going to be any earlier, we can tell you that, but it very possibly could be later, depending on how much time it takes to build the systems to support the final published requirements. And then any delisting would follow that effective date by some time period, at least several months beyond it. So we will be updating these dates as we go along and as they become more into focus and clear as we go. So you can always watch the website for the latest on what these dates are. So that's it for logistics. Now I will shift and provide a high-level overview of the contents of version 5.0 before passing things to my colleagues for some of the more specifics. The purpose of the version 5.0 revision is still very much about energy efficiency. It's to continue to accelerate the broad-scale energy savings, but do so by improving the quality of light and controllability of DLC-listed products. We want to enable differentiation of lighting that both saves more energy and provides comfortable, healthy, and safe environments. We want to enhance the lighting control requirements and information on our QPL in a way that will lead to increased lighting controls adoption. We want to ensure persistent energy savings through products that provide a better user experience. And we want to make the QPL a more effective tool for lighting decision makers to choose products that align with customer needs. There are 3 focus areas of the version 5.0 draft: efficacy, quality of light, and controllability. While our last major revisions have emphasized efficacy improvements, this one is different. Here we are emphasizing quality of light and controllability. That includes adding new requirements or aspects to the requirements that address color quality, light distribution, glare, flicker, circadian wellness, as well as lighting control aspects of dimming, integral controls, and compatibility. Why this emphasis on quality of light and controllability? Let's first start by defining what we're talking about. When we say quality of light, we are referring to the aspects of light that impact productivity, performance, comfort, aesthetics, mood, safety, health, and well-being. When you look at this list, these are really important things. Things like productivity, performance, comfort, health. They are important things for our customers, for businesses, and for people. As research continues to improve our understanding of how light affects human health, wellness, and productivity, we believe it's essential to support development and installation of products whose virtues go beyond just saving energy. The DLC's goal with this new version 5.0 policy is to balance the push for ever-increasing energy efficiency with assurance that illumination supports human comfort, safety, and well-being. So some of the aspects that impact quality of light and that we have made proposals for in this version 5.0 draft are color quality, flicker, glare, lighting for alertness and circadian well-being, and optical distribution. Addressing these things are opportunities. These are opportunities that we can leverage to provide more value to customers. We can provide them lighting that doesn't just save energy, but gives our customers something more, improved lighting for their environment. We can give them better lighting for offices, for hospitals, for schools, stores, warehouses, manufacturing facilities, and outdoor environments. This is also an opportunity to avoid doing something that is not good for our customers. If we save them energy, but we negatively impact their business or their people, then we've done a disservice to ourselves and to them. Lighting is not for energy. That's a benefit it can provide, energy efficiency, but it's really for people. And the excitement for LED and energy savings, sometimes that can get lost. And this is something that we as an industry need to make sure doesn't happen. We are also trying to counteract a concerning trend that we're seeing. It's sort of a race to the bottom. Higher efficacy at the expense of quality of light. Achieving higher efficacy by sacrificing optical or glare control. This puts energy efficiency in conflict with lighting quality when in fact they should work in concert with one another. When these things are against each other, that's a losing proposition. We really want to equip users of our QPL with better information so that they can identify and differentiate the products that have better quality of light performance. The other area of emphasis with version 5.0 is controllability. This is the capability of lighting to be controlled. More controlled lighting can give us energy savings, and that's well understood. It can provide a backbone for IoT and new opportunities and value propositions for lighting that we're really just beginning to realize. But it also has a strong connection to quality of light. We can use more controllable lighting to provide just the right amount of lighting for a task or for a person. We can use more advanced control strategies to change the color or spectrum of light across the day to meet user preferences or even to mimic the sun. And so with this proposal, we are also requiring and encouraging more controllable lighting, both for the energy savings it can provide and for the enhanced value propositions it can provide in providing better lighting for people. With all of this, the outcomes we are trying to achieve are as follows. First of all, we want to continue to work to ensure that the products that are listed on DLC's qualified products list and are referenced by many people in the market are high-performing products. Secondly, we want to make sure that the quality of light and controllability performance of listed products is available, is accessible to people in a way that's not currently on the QPL. Aspects such as glare, flicker are not currently represented on the QPL. And by providing more of this information to enable products that have superior performance in these areas to be differentiated. Third, we want to incorporate information and requirements into the QPL that will enable lighting controls to be more easily promoted and specified, whether we are talking about by a utility or an energy efficiency program, or who's looking to promote products that are more controllable and have potential to provide more lighting control energy savings, or by designers and specifiers that are looking to understand how controllable a product actually is and how it may work or not with a control system. Fourth, we recognize the important role that efficacy can play or plays in energy savings, but not in a way that is going to sacrifice the quality of light. So with these requirements, with this version 5.0 proposal, we are proposing efficacy increases that we want to be at the pace of technology, but not with sacrificing quality of light. And fifth, we are looking to equip lighting professionals with more information so that they can make more informed choices of which products to promote, specify, or use in their projects or programs. With all of this, and most importantly, What we want to see is that the quality of light improves in concert with energy efficiency gains in the built environment. These are the outcomes that we're trying to achieve with each stakeholder. For utilities and energy efficiency programs, we want version 5.0 to help them be able to better identify products that both save more energy and provide more comfortable, healthy, and safe environments for their customers. For manufacturers, we want them to be able to differentiate the increased value of products on our list that have superior quality of light and controllability in a way that's not currently possible right now with the current metrics on the list. For designers and specifiers, and by extension also contractors, procurement, large end users, anyone that is choosing a lighting product for a project, we want them to be able to identify products with verified data that are appropriate for the needs and applications. And then finally, for end users, they're the big winners here. We want them to experience not just energy savings, but more comfortable, healthy, and safe environments and overall satisfaction. These outcomes and our goal to balance the push for ever increasing energy efficiency with quality of light are what have driven the requirements we have put forward in this version 5.0 draft. So now I will pass things to my colleague, Axel Pearson, who will take us more specifically through the proposal for efficacy.
Thanks, Gabe. Hi, everyone. As Gabe said, my name is Axel Pearson, coming to you live from the other side of the country, Portland, Oregon. We were supposed to get snow this week, but we ended up getting about 2 inches of rain. So not quite the same, but still winter weather for us. So I'll be covering efficacy and the flicker topics, but that will come later. So focusing on efficacy for now. And I will be able to change the slide. There we go. Okay, so I think it's important context to take a high-level look back at our previous revisions to the efficacy requirements. You can see that in draft 1 of version 5.0, we are proposing a smaller efficacy increase than we have in previous years, and those range from 17 to 27%. I'll talk a bit about how we arrived at our average efficacy increase of just about 10% over the next few slides, but I want to highlight the general outcomes of our research and outreach to the industry. And really that is efficacy improvements are happening at a slower pace than in recent years, and that continuing large increases in efficacy can have impacts on quality and costs. And Gabe was just talking about that, so we won't go into too much detail there. But our research and outreach supported those findings. So this is really a big driver of our efficacy increases for 5.0. Okay, so our research and outreach really did focus on that relationship between efficacy and quality of light, and also cost. And as a result of our research, we determined really 4 bins of efficacy increase: 5, 10, 15, and 20% increases. And those aren't solid numbers. We usually are rounding to a whole number of lumens per watt, so they may not equal exactly 5 or 10 or 15, 20%, but close. And you'll see what I mean in a second. And so thinking about these 4 bins, we determined where each general application would fall based on how sensitive they were to a change in efficacy, and how quality aspects like color or glare would be impacted by that change in efficacy. And because there are a number of different products, I should say the number of products in each general application varies. The DLC standard classified product weighted average, so this is weighted by the number of products in each general application, resulted in this efficacy increase of 9.6%. And I'll give you an idea of how this worked out. But again, I want to call out specifically that right now we are talking about the standard DLC standard classification. And I'll call that out again, but this is just standard, not premium at this time. And that's something that will come in the next draft. Okay, so here you see the version 4.0 technical requirements table. And so we have our main general applications of outdoor and indoor lighting. And so for the first category, troffers and linear ambient products, we're proposing about a 5% increase in efficacy. And this is because these products are very sensitive to changes in efficacy, meaning they would likely suffer the biggest negative consequences from any trade-offs in quality, particularly glare and color rendering. And these products are also those that are most likely to include networked lighting controls. And we believe that if there's not a large increase in efficacy, those networked lighting controls can capture additional savings. I will ask some folks to mute, please. I got a little bit of background noise there. Okay, so the next category, this next bin of efficacy increase is 10% for outdoor products and also lamp products. And I'll cover the lamps in another slide. But so the outdoor products have moderate room for increase in terms of efficacy, though they may have a greater cost sensitivity. Color rendering is not as much of a concern for outdoor luminaires, but glare is a concern. So this is something we were thinking about in determining where these outdoor products would fall. Again, I'll cover lamps on the next slide, but they have a lower opportunity for efficacy, relatively speaking, because they are sensitive to an efficacy increase in terms of the delisting impact, meaning that many lamps are at risk of being delisted if the efficacy requirements are increased. The next bin is 15% increase, and these are high bay products. So high bay products have a large share of products that outperform the current efficacy requirement by a pretty wide margin. So in other words, there are a pretty good chunk of products on the current QPL that exceed the current requirement of 105 lumens per watt. High bay products are also great opportunities for energy savings because of their longer operating hours and high lumen output, high wattage. So again, the incremental savings potential for high bay products is more significant than other products, and we wanted to take advantage of that. Finally, our last bin of 20% efficacy increase includes interior directional and case lighting. So the current minimum efficacy requirements significantly lag the actual performance by a very wide margin for these products, and thus they can handle a pretty big efficacy increase, relatively speaking. Increasing the interior directional products to something like 80 lumens per watt really brings the category in line with what we would expect from a screw-based directional LED product. Okay, so again, I want to focus on linear lamps here. And this also includes those pin-based lamps, those 4 pin-based compact fluorescent replacement lamps. And they have a proposed efficacy increase of 10% along with those outdoor products. And for those of you that noticed, I didn't cover retrofit kits or mogul-based lamps, and we decided those products will align with the related luminaire general application. So if a mogul-based replacement lamp is going into a high bay application and applying as such, it will need to meet the high bay efficacy requirement. Again, I want to really make it clear because we have received some questions, and I know DLC Premium is a big part of the program. So again, as this is a conceptual draft, we haven't proposed a specific level for DLC Premium or those additional allowances that exist for CCT and CRI, but this is something we'll be thinking about, and we look forward to your input for the second draft. So again, your input is really key to this process. I know that this efficacy section was quick and there is quite a bit of information in the draft, so I really encourage everyone to take a look at the draft that is online, and you can get a lot more information. That draft also includes key questions that we would love your input on. So for a teaser, here's the one question for efficacy of the 3 that exist in the draft. We are interested in further understanding the cost implication of the proposed efficacy increases. We got a bit of information from manufacturers and some other channels of data, but we really could use some data to further support our efficacy increases and make sure that it is cost effective. So we're asking, can you provide any specific information or data as to how the cost of a product may or may not increase with the proposed efficacy levels? So if you have any more information or data to share, that would be great. And we really look forward to your feedback. So again, that does it for the efficacy increase. I will pass it over to Uta, and she'll cover the first sections of quality of light, and you'll hear from me again for Flickr.
Thank you, Gabe and Axel, for setting the stage here, and hello, everybody. Let me check that my controls work. I don't have control yet.
There you go. Try it now.
Okay. Yes, perfect. Okay, thank you, Gabe and Axel. Sorry for the delay. I will introduce 4 of the quality of light topics and summarize briefly what is written into the policy. Apart from the draft requirements that I will go over in these sections, there are definitions and more context written into the policy. So I really encourage everybody to review the information and then let us know any feedback, suggestions, and questions using the commenting process. The information in the policy is based on extensive outreach and literature research that DLC conducted last year. And so, now getting more input through the public commenting is really our goal for the next stage. The first topic I will talk about is color quality. This is divided in color of light and color rendering of objects. So color quality at the fixture level is crucial, and LED technology enables much customization. So color rendering directly influences task performance, for example, by enabling recognizing color differences quickly and accurately. It is also related to occupant safety. It enables distinguishing color-coded messaging and information, for example, in wiring as shown on the picture, or skin discolorations in healthcare. And of course, color quality is a major factor in aesthetics, appreciation of art and design, but also selecting food choices, for example. All in all, it is critical for well-being as an accumulation of all the above, plus contributing to the human experience, visual comfort, and atmosphere in the built environment. There are several requirements that we included in the draft policy for 5.0. The first relates to the color rendering of objects that are illuminated by the light. The 5.0 policy aims to update the current 4.4 requirements to be in line with the industry, and in order to acknowledge that there are different needs depending on the project that the fixture, the luminaire, is for a museum, a healthcare facility, or a warehouse. All those have different needs. We included 2 tiers of requirements, one for baseline quality and the other one for superior quality. For both tiers, the preferred qualification path is now using the TM30 metrics. However, CRI can also still be used as a qualifying path. And the CRI, for example, greater than 80 of the tier 2 is still in line with 4.4. But in addition, we added an R9 red rendering requirement. For all products, both TM30 and CRI shall be reported. The next topic is the color of light itself, more accurately described as chromaticity. Here we also propose 2 tiers. Generally, tier 2 is consistent with 4.4. And for both tiers, we are expanding the requirements to incorporate all definitions specified by NCC 78-377-2017 for correlated color temperatures all the way from 2200 Kelvin to 6500 Kelvin. Color maintenance, it's the product's ability to maintain a specific chromaticity over time. With that, it is sort of the spectral equivalent to luminous flux maintenance over time. And we have a requirement in the draft policy. Again, there are 2 tiers of requirements written into the draft, specifying the acceptable chromaticity shift from the first measurement to one at 6,000 hours or above. While color maintenance is the consistency over time, we also included color consistency from product to product. 3 product units shall provide close to the same chromaticity. Again, there are 2 tiers of requirements specifying allowable variations. In addition, as an optional reporting, we also included angular color uniformity. This is the chromaticity variation throughout the light beam, and this is for manufacturers who would like to differentiate their products. It's only relevant for certain PUDs, for example, track or monopoint luminaires. Now, all these metrics are derived measuring the spectral power distribution, the SPD of the luminaire or the lamp. The policy draft also asks to report an SPD for each product. This is to enable the calculation of other metrics that are not included here or that are also still in development, and so it can help future-proof the listing. For color quality, the DLC seeks to update spectral requirements so that we align with industry organizations' practices and guidelines. Distinguish products that meet a minimum acceptable level of performance, which is basically the tier 2. But also enable differentiation of products that provide superior color quality performance for applications and projects that require it, and that would be tier 1. All this while also avoiding excessive burden or expense on the applicants. We encourage you to review the draft. It includes a list of 6 key questions for color quality. I included here one example. The DLC has proposed defining 2 tiers of color quality, one for baseline and one for projects requiring higher color quality. Are these 2 tiers appropriate? So we would really appreciate any comments, and please submit those through the commenting process. The next topic is also related to spectral quality. It is lighting to support alertness, sleep, and circadian well-being. The effect of light on human biology beyond vision is currently a very popular topic in the lighting industry and beyond. And the DLC is starting to address it to encourage the use of lighting products that can support human well-being by modulating the light spectrum. In order to do this, the draft policy asks to provide information as to a lighting product's spectral properties around 460 to 520 nanometers. This might seem very specific, but this range has been shown to be important for daytime alertness and to impact circadian rhythms and well-being. The overall objective is really to enable product differentiation and to meet needs of applications that have specific demands on human performance and well-being. So the 5.0 policy draft asks to report information and metrics that have been published and provide additional information about the spectral properties of the products that are not yet commonly addressed in the metrics for visual performance. All these metrics are easily derived from the SBD. It's the melanopic flux of the luminaire, the melanopic photopic ratio, and the melanopic daylight efficacy ratio. As already mentioned, the draft for version 5.0 is also asking to report the spectral power distribution that is commonly already measured during the standard test procedures. For this topic, this is very important. It will enable the calculation of other metrics that are still in development. And in addition, the SBD can also be used by related calculators, for example, the circadian stimulus calculator from the Lighting Research Center, to estimate the impact of the light in applications. So DLC's intent is to support industry efforts that address health-conscious design, inform product selections for applications and projects that require it, and to encourage education and innovation in this field. But we are also aware and acknowledge that version 5.0 and the DLC QPL as a whole is based on metrics that can be reported at the product level. However, here, site conditions such as timing, room finishes, light levels, and others, also individual factors, are important additional considerations and factors. There are also still ongoing research efforts to refine metrics and guidelines, and there is still a lack of alignment within the industry on the most appropriate metrics. And especially therefore, we are really looking forward to any of your comments regarding this topic. We also included 3 key questions. One of this as a teaser, as Axel mentioned. The DLC has proposed reporting of the SBD to enable calculation of current and future metrics. What are the major questions or complicating issues here, and what are your suggestions to address them? So we appreciate any comments, and please submit those through the commenting process. As the next topic, I will cover distribution. The optics of the product and the light distribution is really an important and tightly linked factor for energy consumption. By minimizing wasted light, light that falls outside of the target area or creates excessively illuminated areas, it's really, we want to assure that the light, that we have the light where it needs to be. Light distribution also directly influences task performance. We need sufficient quantity and uniformity of light for good visual performance. And as such, it also relates to occupant safety and the visibility for navigation and detecting obstacles. And light distribution is a major factor in aesthetics. It shapes and enhances the observer's interpretation and appreciation of the architectural environment. And it is also critical for well-being through directing the light where it is needed and supporting visual comfort and a supportive atmosphere. Distribution data is measured during standard test procedures using a goniophotometer stored and transferred in a data file, often known as an IES file, and often displayed in a polar plot. Here, not much will change from 4.4. We are asking for the IES file to be reported, and the zonal lumen distribution requirements will stay the same and consistent. In addition, we ask to report the polar plot based on the distribution file to provide additional information to the QPL users. For certain PUDs, we are also asking to report additional distribution information, specifically the beam angle and the field angle. We heard that this is very useful information to evaluate and differentiate products, especially for certain PUDs. Specific to outdoor products, we included reporting of the bug values and bug ratings into version 5.0. The bug values are for backlight, uplight, and glare or forward light, which is based on the lumen output of the fixture within predefined solid angles. And this is already widely used and established in the industry in North America, and it is very useful to evaluate light trespass. So we are asking to report these values. Similar to the other topics, the DLC really intends to update information and align with other industry organization practices and guidelines to distinguish products that meet a minimum acceptable level of performance, enable differentiation of products that provide superior quality for certain applications that require it, but also without placing excessive burden and expense on the applicants. There are no new threshold requirements in the distribution policy. We did look at metrics for task plan efficacy, for example, but decided there are none yet that are ready for any implementation. Regarding the bug values, we included reporting without a threshold, acknowledging that it really depends on the application and the product type. For example, type 5 luminaires are designed to distribute light on the ground in all directions. So a high backlight value, which might mean or indicate poor performance in some cases, here does really not indicate poor performance. With this, we are looking forward to any of your comments. We also, again, included a list of key questions. The one that I pulled out here is that the DLC has proposed reporting of the photometric distribution, beam angle, and field angle. Is this information more useful as a visual diagram or as a set of numbers? What are your suggestions to make this information most useful for the users of the QPL? So we are really looking forward to your comments. The next and my last topic here is glare. Glare is very important to address, especially with high efficacy and high brightness LED luminaires, as both Gabe and Axel already mentioned. It directly influences task performance as it can hinder visibility and distract attention and focus. As such, it is related to occupant safety It can hinder visibility for navigation and obstacle detecting. It is directly related to well-being as it can create annoyance, discomfort, and eye strain. There are 4 known discomfort glare factors: the luminance of the glare source, the size of the glare source, position of the source in the field of view, luminance of the background. So these are the 4. Some of these are product specific and can easily be addressed, but others depend on site and implementation, which makes it a tricky topic to address. I already covered reporting the distribution data using the IES file and the bug value information in the distribution section. So I covered it here again. It is the same information that is included in the distribution section. We have written it into both policy draft section because it is as relevant for glare as it is for distribution. But it is the same reporting requirement. For indoor lighting, the draft asks, in addition to report the Unified Glare Rating, UGR in short, using the reporting of the UGR table. The UGR is the Discomfort Glare Likelihood Assessment method, which was developed and published by the CIE. It is calculated using IES distribution data and software tools. And the UGR table refers to a set of values of the luminaire tested based on a preset room definition. Therefore, it is an estimation. However, it is useful and gives additional information on the likelihood of glare that a product, like a luminaire, can produce. The DLC seeks glare requirements that, again, align with other industry organization practices and guidelines, provide basic indication on the likelihood of causing performance concerns and glare in the field. We do want to enable differentiation of products that have good optics and provide good glare control, but as well don't place excessive burden on the applicants. UGR is more widely used in Europe than in the US, and the research into the glare metrics is also still ongoing, so we are acknowledging this. And for outdoor lighting, the glare in the bug system relates to the forward lighting at high angles, and with that it actually relates most closely to the driver glare rather than pedestrian. And for pedestrian, lower angles can also easily cause discomfort. So on the topic of glare, we really are looking forward to any of your comments. We also included, again, 6 key questions. The one that I pulled out here as an example is the DLC has proposed reporting of the UGR tables for indoor luminaires using the luminaires IES file. What are the questions, complicating issues that you have with this proposal, and what are the suggestions to address it? And so for any comments, please submit through the commenting process. And with that, I thank all of you for your attention, and I will hand it over to my colleague Axel to cover Flickr.
Thank you, Uta. All right, our last quality of light topic, Flickr. Give it a second to be able to switch. Here we are. Okay. Great. So again, I'll be covering this quality of light section on Flickr. So I want to revisit something that Gabe mentioned, and I think this applies to obviously all of the quality of light topics, but for Flickr especially, that one of the main goals of version 5.0 is to mitigate potential negative impacts from lighting. And I think that low flicker operation in luminaires is a really great example of that. And here we have some evidence here. Flicker-free operation is a critical component of visual comfort, as flicker can be simply annoying and cause a loss in productivity, as I'm sure any one of us can understand who's been under a flickering light. Flicker it can not only be annoying, but it can have health impacts that can range from eye strain to migraines, anxiety, photoepilepsy, a bunch of really nasty problems. And flicker can cause dangerous industrial working environments by making rotating machinery appear slowing or still when the frequency of flicker approaches the speed or like the RPM of spinning parts, which can clearly be really dangerous in that environment. And flicker can interfere with machine vision and imaging devices like barcode scanners, sensors, and video feeds. In fact, that's kind of a layman's way of detecting flicker, right? Is to take a slow motion video with your smartphone and see if you can see the light modulation, which I often do, just going around looking at lights. So let's move on. So for definitions, you may have noticed we are using the term flicker to generally describe temporal light artifacts, or TLA. Which include 3 categories of light modulation over time. So when we say flicker, we are including these 3 different types of light modulation. The first of which is flicker, which is light modulation with relatively low frequencies, somewhere between 0 and 80 hertz. We also address the stroboscopic effect, which occurs between 80 and about 2000 hertz, and also the phantom array effect, which occurs between 80 and 2500 hertz, or even higher, some of the research I found. So though we do address each type of flicker in the minimum requirements, we are proposing 4 flicker metrics. So 2 on this slide, and I've got 1 more slide with 2 more metrics, though only these 2 of the metrics have thresholds to meet for listing on the qualified products list. So the first one is in the first row of this table. It's short-term flicker, denoted PST, and this covers that low frequency flicker below about 80 hertz. We have set the maximum threshold at a PST of 1.0 as recommended in the NEMA 77 document that was published in 2017. And so this must be met at 100% light output and 20% light output, and then reported at minimum light output. But again, the threshold, we are proposing that it be met at just 120% light output. The next metric is the stroboscopic visibility measure, or SVM, which we are proposing a 2-tier maximum threshold. So the lower of which is an SVM value of 0.9 or less, and the tier 1, or the more strict tier, to be 0.4 or less. And so this SVM value is also described in NEMA 77, but we are basing these lower thresholds on recent research that really an SVM of 0.09 is really the lowest acceptable amount of flicker, meaning that 25% of the population will detect the flicker or the stroboscopic effect 63% of the time. And SVM of 0.4 means that just 10% of people will detect that stroboscopic flicker. And so based on our research and outreach with the industry, we believe that these are the acceptable levels of stroboscopic flicker. The third and fourth metrics that we are asking for are percent flicker and flicker index. These 2 do not have thresholds associated with them, only reporting requirements. And for those savvy viewers, the reported values might look familiar. They are based on California's Title 24 requirements in JA8 and JA10. The reporting requirement for percent flicker at 100%, 20%, and minimum fraction of light output for these cutoff frequencies of 40, 90, 200, 400, and 1000 hertz. And then while California's standard uses percent flicker, we've also included flicker index, as this metric accounts for things like the waveform and the duty cycle of the flicker, which percent flicker does not. So for all four of these metrics, I'll go back to show you under the method of evaluation. Oops, maybe I can't go back. So the method of evaluation is the same for all four metrics. It is the ANSI IES approved method titled Measuring Optical Waveforms for Use in Temporal Light Artifacts, TLA Calculations. So this document is not yet published, but it does have a 19 in there, meaning it is expected this year. Okay, so our considerations for these metrics really revolve around a lack of consensus within the industry around the proper metrics and appropriate thresholds. So we did quite a bit of research and outreach on this and heard a lot of different opinions and thoughts on flicker. And ultimately, we at the DLC, we want a flicker requirement that is clearly understood and also easy to compare between products, so users of the QPL can make a distinction on what level of flicker is most acceptable for their application. So to address these considerations, we really based our draft requirements on the two dominant perspectives that I mentioned, which are NEMA 77, the PST and SVM, and then IEEE PAR 1789, which is kind of the foundation for those California Title 24 metrics. Okay, so as with the other topics, we are looking forward to your feedback on this issue, and Flickr also has 3 key questions. Here's the teaser. So DLC understands that the current family grouping structure of the QPL may not support the reporting of Flickr metrics, and testing each product would be overly burdensome. So how can the DLC ensure that products meet the DLC requirements without testing each product? So keep that in mind. There's 2 more key questions in there, and we really look forward to your help answering those key questions. That is it for the quality of light topics, and I'll pass it on to my colleague Damon Bazzetti, and he's going to cover controllability. Thanks again for listening, and Damon, you're up.
Thank you very much, Axel. I appreciate it, the great introduction, and thank you to all the previous presenters and to our audience for your time today. I will be speaking with the controllability aspect of our 5.0 plan, and I'm pleased to share with you the work that we have done on this to date. Why is DLC doing this? Why are you thinking about this? Well, we're focusing on controllability because our stance is that while source efficacy is crucial, there is still a tremendous opportunity for even more savings. In large swaths of the built environment, controls have a usage or adoption rate below 10% or even 5% of the building stock. We know we can certainly do better, and so we want to make it easier for people to do what we view as the right thing. The ways that we're going to do this is to first reduce the rate of uncontrolled installation jobs. Because of the excellent product life of SSL products, thanks to the hard work of everyone in the industry, many of you on this call, they're going to stay the way that they are installed for quite a while. So something that may have previously been serviced or replaced on a more regular basis every 18 or 24 months will have a much longer cycle of time before someone's on a ladder touching it again. Next is we want to make it easier for people to, once they have selected a product, choose the way that they are going to control it once they've been convinced of the value of controlling it. In a lot of our research from stakeholders, this was an extremely common thread of there was a lot of stitching together of information from various manufacturers and various data sources that just increased friction in someone trying to figure out how to do controls with a product. So we want to make that easier, because the easier you make it, the more people will go down that path. And then third, we realize that even in the most ideal situation, products will get installed without controls. However, if there is some kind of latent ability or compatibility that is built into there, it might be more economically activated later on. And so maybe at year 3 or 4 or 6, there's still some opportunity to go up there and grab some extra savings that way too. And this is, I guess, a little bit more of a quantitative analysis as to what we think the impact of this extra focus on controls adoption can do for the national lighting energy picture. The light green picture is what network lighting controls do with increased utility support. And you'll notice that both the increased volume, or the amount of savings, increases, and also it extends the amount of time over which we can achieve meaningful energy savings, which I think everybody in this industry is interested in maintaining both the duration and the volume. All right, well, great. You've convinced us about how about the value of this and the usefulness in the 5.0 effort. You might be asking yourself, how is DLC proposing to do something about this? Well, there's 3 things that we have proposed or outlined in our first draft we'd like to hear from you on. The first is to enhance reporting on the availability of integral controls in products. Not to require, but to simply provide more information of a more detailed or granular aspect. The next is to potentially require dimming for most, not all, usage designations or categories of fixtures and lamps on our qualified products list, on the idea that once everything is dimmable, that will remove a significant first assembling block at getting products through the project design and implementation pipeline. That will result in them being controlled. Finally, to enhance reporting on controls compatibility, and I'll talk about this a little bit more in a later slide, but this is going to be a very first pass approximation of controls compatibility. We do not mean interoperability. We do not mean verifying vendor and OEM relationships. We mean to answer a very simple and very basic question at, will this light fixture be controllable by an arbitrary off-board source? So first, to the dimming question. As you can see, currently we are requiring the reporting of dimming capability for all products. There are a few options for how to do so. What we are proposing to do in the first draft requirement is to basically require it for almost all products, with excluding categories like hazardous location, case lighting, low output landscape floods. There are a few others that you can read in more detail in the draft. Ones that did not seem by their nature to be inherently needing controls or controllability, or I'm sorry, dimming inputs. We would be requiring continuous dimming for indoor products and stepped dimming for outdoor products, on the basis that the user requirements for a continuous dimming experience are not quite there for outdoor, and stepped is, for lack of a better term, good enough. Always want to be conscious of how price is affected by various technical requirements. And then we're proposing to evaluate it by simple product documentation. You might be noticing from that image that not all dimming curves look alike. We want to hear from you about the balance of brevity and detail that QPL users would need in order to understand this in a meaningful way. Next would be the section on enhanced reporting on integral controls. So currently we have optional reporting on this, unless it's a premium product application, in which case we require reporting. It's simple, basic yes/no answers for some course answers, or some course questions. What we're proposing to do in the first draft is to require everything to go on the record and say yes, no for a more detailed set of characteristics that mostly revolve around controls, but also revolve around potentially sensors and metering. So one thing that might be useful to users on the QPL is I want to I only want products that can demonstrate energy metering. There are some utility programs of DLC members that are requiring energy metering for participation in their network lighting controls projects. Being able to cross-reference for fixtures that could support that might save people and utility programs some time. Temperature is another aspect, certainly daylight harvesting and occupancy sensing, but we also want to hear from you as to what other standardized reporting on absence or presence at the product level would be useful. Finally is controls compatibility, and this is something that we really wrestled with because this is a very detailed and complicated question. But what we settled on was requiring those products that are requiring to do, which is most of them in the proposal, to report the method of inducing dimming behavior in the product. It's very carefully worded. I want to highlight here that we understand that LAMP form factors do present challenges for receiving commands from an external source. It's either something probably coming in through the power connection or a wireless command. And we do want to be sensitive to application needs and what's out there. So this is where our draft is explicitly proposing to count techniques like phase cut, line voltage modulation as an option here. But the idea here is that for the product that does dim, you would be able to see what is the way that you ask it to dim, whether that be through a 0 to 10 line coming in, a DALI line, phase cut dimming, or wireless control or something else. So we'd like to hear from you as to your thoughts on this proposal, the coarseness or fineness of the data that would be reported to be useful to various QPL stakeholders, and so on. Like my esteemed colleagues before me, I'd like to point you to the full text of the draft policy as well as our detailed comment form to help us make sure that we're capturing the depth and nuance of your suggestions and questions. We've highlighted several key questions on the draft document specifically about controllability. Please don't let that limit your answers, though. If you think that we've overlooked something, then it's very important to us to hear that from you. So please get your comment forms fired up, filled out, and sent back to us. And we're looking forward to working with you to advance this specification to the next step. That's it for me, Axel.
Thanks, Damon.
Okay, this is Gabe again. Thank you, Damon, and thank you, Axel and Uta. I'd like to draw your attention to the last section of the draft, but it's a very important section, something we've called other topics under consideration. These are topics where we haven't made specific proposals in this draft. These are things that we're thinking about making proposals for in the next draft, but we're not going to be able to do all of them. And so we're looking for feedback from you on the order of priority of these different items. In addition, whether or not you support the DLC addressing these topics as they are proposed in the draft, and any major issues or concerns you have with what is proposed. There are some big meaty things in here, important things. Things like redefining DLC premium, which is currently a designation primarily for products with higher efficacy, to be a designation for products that might demonstrate not just energy efficiency, but high quality of light, leveraging some of the additional quality of light metrics that we are proposing to include on the QPL. It includes this concept called a DLC product information sheet. You might be asking, DLC is proposing to include all this additional, very technical reported product information. How would you make that information usable, digestible by users of the QPL? Well, this might be one way to do it, through a DLC product information sheet which summarized this technical information in a way that was could be better understood by users of the QPL. For example, we could use graphical indicators to indicate the potential for glare from a product rather than printing the numerical UGR values. And you could do that with many of the metrics that we are proposing to report. So you can find a description of that as well in this section of the draft and what we're thinking there. It also includes a couple of topics, non-standard form factors and something called platform qualification, which would be developing a new means for some product types that are currently challenged with qualifying their products with the DLC, and in turn with fitting them into utility energy efficiency programs. The DLC's product categories, PUDs or primary use designations, as well as a lot of the utilities product categories are really defined or structured around standard form factors, things like high bay fixtures and so forth. And some of these product types which are doing some innovative things and developing new types of form factors and shapes of luminaires, taking advantage of what LED has to provide, are challenged with fitting them into the DLC structure. So these might be two methods to enable those products to qualify with DLC. Another one is the topic of reference housings, where we are considering either eliminating or changing the requirements for lamps to be tested inside reference housings. And then finally, a proposal to report products that may be dark sky friendly. So we'd like to hear from you on the order of priority with these, because we can't do them all, as well as any major issues or concerns that you see with them. So for next steps, comments are due to this first conceptual draft on March 12th. So that's coming up next month. We'll be taking those comments and bringing them to the DLC stakeholder meeting in St. Louis beginning on April 1st. If you would like to hear what we have heard from everyone in terms of comments and be part of the discussion and how we move forward around them, this is an event to be at. So we hope that you'll be able to join us there. From there, we will be developing a second draft currently proposed for June 3rd. Comments would be due on that in July before a final release in October 1st. As I said earlier, some of these dates might be subject to change. I think I can confidently say they're not going to be any earlier than what you see here. Actual qualifying of products would be sometime in 2020 as currently proposed. So this stakeholder meeting is a really important event, and it's April 1st through 3rd, again, in St. Louis. You can find information on our website, and we want to encourage you to be there to be part of this conversation and how we move forward with all of what we've discussed here today. So that wraps us up. I want to thank my colleagues Uta, Axel, and Damon for their contributions to this presentation, and especially all the work that they have done in building this proposal. It was a lot of work. We talked to over 100 people. We had hundreds of survey responses and countless hours of research in developing what's been proposed here. These are really complicated topics, controversial issues, and they've really tried to strike the right balance and where industry is at, where science is at with all of these proposals. And we especially want to thank you again for your time and participating with the DLC on this webinar with us and in reviewing the draft and providing us comments. Your input is absolutely crucial to developing a policy that best works for everyone. So I think that's it. We hope to see you at the stakeholder meeting in St. Louis, and we hope that you enjoy the rest of your day. Take care.